Okay, in this video we're going to look at derivatives of polynomials, and the first and the most simple polynomial we can look at is just the equation of a line. So equation of a horizontal line. In this case, this one is y equals 4. It is the horizontal line that passes through 4 on the y-axis. And so this function is a constant. So the derivative of a constant, if you think about it, when you find the derivative, you are finding the slope of a tangent to this curve. Well, what's the slope along that curve at any point? And that is actually 0. So the slope of any one of these lines, whether it passes through 4 or 3, 2, 1, minus 1, anywhere, it will be horizontal, and the slope of those will be 0. So in general, the slope of any constant value is equal to 0. So if my equation is y equals 100, then y prime is equal to 0. Or the other notation might be dy dx. The derivative of y with respect to x, even though we don't see an x in the equation, it is there in a way. It's x to the 0. Okay. Moving on to the derivative of the nth power of x. Let's see that one. So the derivative of the nth power of x, the formula tells us that if we have a term or a function that is x to the n, and that we're taking the derivative of that function with respect to the x variable, then we take the exponent and we multiply it by the coefficient, and we reduce the exponent by 1. And so let's look at this example. We have the curve y equals x squared. That's here. This is y. I'll do that part in red. This curve here, y equals x squared. And when you find the slope of a tangent to the curve, you're finding the slope of a tangent line at any point along the curve. The formula will give you the slope of a tangent in general for any point on the curve. I've drawn one of them at x equals 2. When you sub in the x value, then you get the actual slope. So let's do this one using the power formula here. We've got y equals x squared. And so this is our n. Okay, that's n. So the y prime then is n multiplied by the coefficient, which you don't really see, but it's a 1. All right, so if it was another number, we would multiply it. And then x is no longer raised to the power 2, but it's raised to the power of n minus 1. So we reduce it, now it's raised to the 1. I'm going to write a 1 just to exaggerate that. It's a 1 and you don't want it to be missing. So to make it a little bit neater, that just becomes nx. So the derivative of our y equals x squared, its derivative, y prime, is 2x. That means the slope of any tangent to the curve y equals x squared is 2 times x. And therefore, when we change different inputs of x, so in this case I've put in a 2, the slope at this point where it's touching, the slope of this tangent line is 2 times 2. So at x equals 2, then y prime is equal to 2 times 2, which is 4. So this tangent line has a slope of 4. It will be different if I draw a tangent line somewhere over here. All right, not that one, but I'll undo that. Right there. All right, that's at minus 1. The slope of that line at x equals minus 1 then y prime is equal to 2 times minus 1, which is minus 2, right? So it has a slope of minus 2. And the slope will vary anywhere along that curve. Okay, so another example. The curve is y equals 6x cubed. Then our y prime is equal to, take our exponent, multiply it by the coefficient, so 3 times 6, keep the variable x, and reduce the exponent by 1. And this becomes 18x squared. The derivative of a sum of different terms, of different powers of x, then, is the sum of their derivatives. So if we have a first term, we find its derivative with respect to x. And then we have a second term, we find its derivative with respect to x, and so on. So my example actually has 3 terms, and it will just be the sum of those derivatives. So y prime, let's do the first one. 4 gets multiplied by 5, x, and the exponent is reduced by 1. We'll write out all the details for this line. Plus, move on to the next one. 2 gets multiplied by 4, x, and we reduce the exponent by 1. Don't forget in this last term that that's actually an x to the 0. It's a constant, right? And the derivative of a constant is 0. So we don't want to just leave it as 8. Sometimes that's a common mistake. Remember that the derivative of a constant is 0. So what does this look like here? We've got 20x cubed plus 8x. And that's its derivative. All right, thanks for watching. Bye-bye.